Hello everybody, and thank you for watching this video. I hope that you are going to enjoy it. Since you are watching this video, I will go ahead and assume that you are thinking about moving your Tyro 129 or 119 from Betafly to Inav. I have made a switch about a week ago, maybe a little more than a week, and I have to tell you everything is working fine on my Tyro 129. I already posted a video about it, so feel free to watch it. I'm going to put a link to the video here. But in this video, I'm going to be showing you what you need to do in order to get Inav to run on your Tyro 119 or 129. There's a couple changes you're going to have to get on your drone first in order to get the system to run efficiently. But before I get to that, let me talk a little bit about some theory. In order to run Inav on any system, on any quadcopter, you need to have a GPS module. And the GPS module is going to be what you need in order to get your GPS coordinate. That's going to be your longitude and latitude. You're also going to need a barometer. That will be essential in order for you to get your altitude. And last but not least, you're going to need your compass or a magnetometer. And that is what Inav gonna need in order to get your aiding. Okay guys, so before we go any further, I feel like we need to talk about aiding, and that will help you understand why you need to have a magnetometer or a compass on your drone in order for Inav to work efficiently, especially if you're planning on using any of the autonomous flight mode. Inav use aiding for two reasons. The first one is to figure out which direction your drone is flying, and the second one is to figure out which way your drone is facing. And this is only an issue if you are using your Inav on a quadcopter. It's not an issue if you are using it on a plane, because a plane only fly one way. Where we know quadcopter, this is going to show you my little tower here, can either fly forward, sideways, or backward. So heading on Inav let you know which direction you're facing and which direction you are traveling. And I'm going to show the compass here. Let's just think of this compass as your drone. And right now we have our heading here, which is facing this way, and this is the position to the magnetic north. So think about it. This is how we're facing. This is the front of the drone. So if you start turning a compass to the left side, which is west, our heading has changed. The north still the same, and now we are facing this way. And this is what Inav need to know in order to determine which way you are flying and which way your drone is facing. And like I said earlier, it's very essential if you are planning on using any of the autonomous flights on Inav. Now, GPS module, in this case, I'm going to show you the BN220, does also provide aiding, but it provides aiding in a delay, and it's only provide aiding when the drone is actually moving. So let's say we're not using a compass, we're just using a GPS module, and it gives us the data for the aiding. So Inav know we are going this way and we are facing this way. Actually, it does not give you which way you're facing. It only gives you which direction you're going. The BN220 does. So we are going this way, and we stop. Now you're hovering. The data on the GPS has a little bit of delay, and you switch and you start going this way. The only problem about this GPS is that eventually it's going to give you the data that you are going this way, but it's going to take a little bit of time. And let's say by the time you are going this way, you go into Failsafe and your return to home flight mode pick up. The only problem is, since you haven't got the data yet that you are going this way now, your Inav still thinking you are going this way. And you can see where that may be an issue. I hope I can explain the best I could, guys. But just remember, the big thing about it is you need a GPS module with a magnetometer in order to get the proper aiding. And with the magnetometer, the aiding is constant the information still going to Inav. So whenever you change position, Inav knows it right away and know exactly which heading you are going to and which way your drone is facing. Alright, so this is going to be a first change we're going to be making to our drone. We're going to be switching from the BN220 to the BN880. This is the old one I have. Inav actually recommend you to use the BN880, but there is multiple GPS on the market. There does come with a magnetometer, but the BN880 is a good choice because I think it is the cheapest one you can get. This one goes about $15 to $19 depending on where you get it. Of course, it does come with the magnetometer. That's the one on the bottom, and your GPS on top. So that'll be the first change you're going to be making. But since we're going to be using the BN880, you may also think about using a mast. Let me see if I can get it. This is the mast I'm using. And the reason we are using a mast is to keep a magnetometer away from our drone. And I'm going to show you a little example here. I'm just going to use my little Tyro 79. And as you know, our drone is very noisy. That's one of the reasons we have to use filter in order to keep the noise from reaching our flight controller. And just think of noise as interference, and those interference may also affect your magnetometer. It's working, and I'm going to show you an example how a drone can affect your magnetometer or a compass. So I have my drone here, and I'm going to plug it in. So I'm going to put my compass on top of my drone. As you can see, nothing changed. Now pay attention to what happened when I arm my drone. Let me put this in the middle. What? Why are you not harming? There you go. All right. Now just pay attention to the green arrow. As I increase, you see how it's moving? And I'll stop it again. And now we're back to where we're supposed to be. That is your magnetic north pole. And let's move it again. If I harm the motor again, you're going to see it's going to start moving. And this is just interference from our drone due to the noise the drone make. It's really called electromagnetic field. It does interfere with our GPS or compass on this time, in this case. So now we start it again. As soon as the motor starts spinning, you can see my green arrow start to move, and then again that's just interference from the drone. And it does the exact same thing on your magnetometer or your compass. If I go up, and when I turn it off, you give it some time. Now my compass is pretty much off, and this is why you need a mast to keep your compass away from the rest of your drone. See, when I move the drone away, I'm back to the magnetic north. So let's recap what we covered so far. In order to run Inav on your Tyro 129, you're going to need to have a mast. And I picked this one. It's available on Banggood and eBay. Price range from $2 to $8. So be very careful about what you're buying it for. I seen on the eBay as low as $2, and this one I got from Banggood, it was $8, and I got 2 of them just in case I crash and I break it. But it seemed to be pretty sturdy. It seemed to be pretty hard. The thing I like about this one is that you can screw it directly to your drone, so you don't need to find a way to attach it to the drone. You just screw in place, and that's very nice. And we also do need our BN 880 because we need the magnetometer, to get our heading, and we also need to keep the BN 880 away from the drone because of interferences that can mess up the data on the compass. Wiring the BN 880 is very simple, and especially if you already build your Tyro and you already use the GPS module, that should be pretty easy. It's very straightforward. And this is a picture of the F4.com, F4 flight controller that come with a Tyro. Sorry about that, guys. And here is your ESC connector. This is your camera connector. And the one we are more interested with is this plug here. This is where your GPS go. And wiring it is very straightforward. You have your 5 volts, you have your negative. This is your TX1 and this is your RX1. And remember, guys, when you wire it with your GPS module, TX1 and RX1 are flip. And this one here, those 2 here are your R2C. And this is what you need to wire in order to get data from your compass. And of course, you got 2 options to wire your GPS compass on your F4. You can use this connector here, or you can just do what I did. This is the bottom side of the flight controller. You can just solder it in here. Let me see here. Here we go. You can just directly solder it to your flight controller, and same thing. You're gonna get your 5 volt here. You're gonna get your negative volt. You're gonna switch your TX and RX. So TX gonna go to RX on your GPS module, and RX gonna go to TX on your GPS module, and SDA gonna go to SDA, and SCL gonna go to SCL. And this is a picture of the pinout of the BN 880. And of course, same way, that go to SDA, that go to your gun on the flight controller. We're gonna switch our TX and RX, so that gonna go to RX on the flight controller, and this is gonna go to TX, and this is gonna go to your 5 volts, and this is gonna go to your SCL on the flight controller. Alright, guys, another thing I need to bring to our attention is Inav Telemetry. Inav Telemetry is pretty much a Lua script for Inav, and I'm not going to show you how to download it. I mean, it's pretty easy. I'm going to put a link to the download file in the description section of this video. But what Inav Telemetry does, let me show you. And I'm using a QX7, that's my controller. It may be different for your controller if you use something else than FreeSky. And Inav Telemetry can give you data about your flight controller. I don't have my Tyro 199 plugin right now, but if you go to page, this is what Inav Telemetry look like. Give you data about your satellite number. It give you all kind of coordinates, and you got 3 different pages. No, not this one. There you go. That's the first page. That is your second page. And that is your third page. You got your magnetometer in the middle. It's very nice. It does move directly as you move your drone. But I don't have my drone plug-in right now. That's something you can have. Of course, it's not really useful for people that fly FPV, but it's still something you need to have. We have made all the change we need to make to our drone in order to run Inav. Now let's get to the fun part. Let's go ahead and plug in this drone and go into the configurator. By the way, guys, I'm not going to show you how to download the configurator. I mean, I'm not going to insult your intelligence. I'm pretty sure if you got to this point, you know how to download the configurator. Okay, so there's a couple things that need to be done before flashing Inav to your Tyro 129 or Tyro 119, we need to back up our file just in case we want to go back to our beta flight. And to do that, we just gonna need to go to a CLR command, and we're just gonna tap diff. And these are all the files we have on beta flight right now on our Tyro right now. You're gonna go to save. You're gonna save your file. I'm not gonna go to the processes. You can see I already have my beta flight backup file saved. So this is just in case you want to go back to beta flight. So that should make the transition back a lot easier. We're gonna hit save, but I'm not gonna do that right now. Another thing we also need to do is we're gonna tap version, and this is what we are after. This is a target for the Tyro 119 and 129 is the same target, is the Metec 405, and this is gonna be a target for Inav. I'm not gonna show how to flash Inav, guys. Alright, so let's go ahead and connect. Alright, so this is gonna be what you're gonna first see once you connect to Inav. It's gonna ask you for the default value. We are using a 7-inch quadcopter, so you're gonna use the 3 to 7-inch propeller. And now what I want you guys is gonna go ahead and reboot, and when we come back, I'll give you some more data. So yeah, we are back on. You get this little red message here. Do not worry about it. You don't need to worry about it. Just ignore it for right now, because it's gonna go away after we go to all the different tabs. We're gonna get this one fixed already. And also everything is blank here. For right now, the only thing Inav is seeing is a gyro and accelerometer. And as we go to the different tab, we're gonna get all those activated. It doesn't really matter which order you go to those tabs. What I like to start with is of course the Port tab. And one thing, I don't know why this here keep coming up on. It's actually on. So what we need to do, we need to turn this off. And I don't know how you guys set up your flight controller, but just make sure you use your UART according to whatever way you got it set up. On my setup, I got UART 1 for GPS, and I'm gonna change the baud rate here. The baud rate for the BN880, according to what I found online, is supposed to be 38,400. So that's done for UART 1. The UART 2 is a serial port, and I'm using a FreeSky R9 module. I'm using a FreeSky R9 receiver. I'm using the Sling Plus receiver, so that is UART 2. And on UART 3, that's why I have my VTX. So we're gonna use VTX Smart Audio. And I'm not using UART 4 and UART 5, that's where I have my smart port. And this is how I got mine set up. So just make sure you assign your UART according to how you have your flight controller set up. We are gonna go and save and reboot. So we are back now, and look like it took all my changes. Next place I like to go to is the configuration tab. And here, that's where we're going to set up our GPS and or a different sensor. And as you can see, my Inav already recognized that the accelerometer I'm using is the MPU 6000. And you can see here, it's already saying it. It's saying the accelerometer and the gyro. Okay, so the magnetometer for our BN880 is the HMC5883. You can actually choose the automatic option, but since I know which one it is, I'm picking this one. So, and if you are using a different GPS module than the BN880, make sure to find exactly which magnetometer I use for your GPS. This is pretty much your compass. And a barometer for our flight controller is the BMP 280. So we got this one down, and that's the only thing you have to change here. and we're gonna go down to our board alignment. Now I got my flat controller just the way it was supposed to be done, so you don't need to touch here. If you got your flat controller in a different position, of course you need to make the changes to align your flat controller with whatever position you choose. But what we are really interested here is the magnetometer alignment. And with my BN880, I have it to where the plug for the wire are facing backward, and of course the GPS is facing up, so we're going to be using this setup. It's a CW270 flip. If you have your magnetometer on a different setup, your GPS module set up differently, just make sure to come here and make sure you pick the right alignment. But the one I'm using right now, we got a connector facing backward and a GPS facing up, so this is the alignment we need. And we're gonna go downstairs, go down a little more, and we're gonna set up a GPS. I got U blocks, that's what we have. And I'm gonna set up a ground assistance to North America. That's where I am right now. And also, we already have telemetry output out, so that's fine. So that means Inav Telemetry should be working. OSD is on. And that's pretty much anything you have to do here. Do not worry about the VTX. VTX is working fine. You don't need to do anything like in Beta Flash 4.1, which I think it was stupid. Oh God, I'm digressing here. I'm gonna save and reboot. So in order to get data from your GPS module, you need to plug in your drone. So I'm gonna go ahead and plug in my battery to my drone. Alright guys, so I have my battery plug in, and now you can see we are actually seeing a GPS already. It is in blue. We are still not seeing a magnetometer or a barometer, and we're gonna get to that next. What we need to do now, we're gonna go into calibration. We are gonna calibrate our accelerometer. This works a little different than Beta Flight. In Beta Flight, you only need to put your drone on a flat area and the software does everything. But there is a couple steps needed on your for Inav. Sorry about that, guys. And it is a pretty simple process. What we all need to do, we're going to just tap in calibrate accelerometer, and you get this little warning sign, and we're going to go to push OK. Okay, now we're going to go again. Let's try again. Calibrate. Here we go. So now it's processing. There we go. This is the first step. You got to match your drone to the different position. Now what I'm gonna do, I'm gonna flip my drone upside down and hit calibrate again. Now we got a check mark. Now I'm gonna have my drone facing the right side. Hit calibrate again. Now I have my drone facing up, and guys, this is based on how you have your flight controller installed on your quad. I'm gonna hit calibrate again. Now I'm gonna have it facing left. And I'm gonna have it finally facing down. Here we go. Calibration is done. We'll go ahead and save and reboot. Alright guys, so now we're gonna go ahead and calibrate a compass. Don't pay attention to here. According to this, a magnetometer has been calibrated, but it is not because you got all the zeros here. So we're gonna go ahead and calibrate it now. Once you push the button, it's gonna give you 30 seconds to do the calibration. And what you need to do, you need to tune your quad 360 degrees on the X, Y, and Z axis. But what I'm gonna do, I'm gonna tune my quad about 720 degrees on all three axes. So we're gonna go ahead and start. Alright, so we have this number here, which means a magnetometer has been calibrated. And one way you can check that is if you go to your setup and pay attention to this number here. If you move it, it is actually moving, and this is about magnetic north on my side, which is 0 degree, and everything is working fine. One thing, guys, I forgot to let you know, you can see here too, everything is checked now, so that's good. And another thing I need to let you know, guys, just to save your VTX before you plug in your battery, just go ahead and disconnect your VTS. It will keep you from frying your VTX when you're doing all the setup. And now we got calibration done. We're gonna go to a mixer. You can see now I'm now seeing all the sensor. From here, it's gonna be depending on how you got your quad set up. I have mine set up just the way it's showing the picture. You got model 1, 2, 3, and 4, and I have my props going clockwise. If you have your clocks going counterclockwise, you need to change it here. But for right now, the only thing I need to do is just load and apply. Action override auto current mix. Yes, that's fine. We're going to save and reboot. There we go. And that is all we have to do on this tab. We are using a multi-rotor, so we don't have to change nothing as far as for doing. If you're using something else, then you got different option here. We're going to go to our output. And one thing you have to do here first is we have to turn this on. And our ESC, I'm going to be using D-Shot 300. You can use D-Shot 600 if you want to, but I'm going to be using D-Shot 300. You don't need to worry about servo refresh rate. We don't have a servo. And on your motor auto, I'm going to lower mine to about 5 to 7. I'm going to keep it to 5 or 7. It doesn't really matter, but you can see it does give you a message here that if you're using D-Shot, you have to lower your auto. So we're going to go, I'll go to 6 just to be in the center. And we're going to save and reboot. So now I'm going to go ahead and test my motors, make sure everything is spinning. If you have already set up your drone before with beta flight. Oh, sorry, Amber.
GPS lost.
That's just Amber talking to us. So, if you have already...
GPS good.
Oh my God, this is going to be annoying. If you have already set up your... It's actually pretty good. I'm getting GPS and in my basement. That's pretty amazing. And that's just Amber let me know I got some GPS. Now, if you already had your drone running on beta flight, your motor direction should be white. I got my pops off, and I just want to make sure the motor is spinning. So you're gonna turn this button on to understand that we're taking the risk. We know what's going on, and motor are spinning fine, and the direction should be, as I say, if you already set it up earlier, you don't need to worry about your motor direction, but I'll go ahead and just check to make sure. So that is fine. We're gonna go ahead and save and reboot again. Just to... Now we're gonna go to the preset section here. Give you option as those are presets, flat mode or setting. Give you option for endurance or freestyle. But good. Shut up, Amber. But I'm gonna skip those. I'm not gonna be using them, and you can pick one of those. You got endurance, and let you know what you gotta do. You gotta run multi-shots. That's why I don't want to run it, because if I believe if you run, I don't know, I never run multi-shot, so I'm not. That's why I'm not using the endurance section. I'll go to the next part. We did that already.
GPS good.
We already did a configuration part, so we're gonna skip that. Failsafe. Now, this is what gives you the option of what you want your failsafe to be. For right now, we got it on landing, and we are using a throttle value of 1,000. Now, I have increased my throttle value to 1200, because 1000 is literally your motor gonna stop spinning. So 200, that's what I'm using. Actually, let's do 250. And I'm gonna switch it to RTH, which is return to home. And again, we're gonna save and return and reboot. This should be it. As far as PID tuning goes, I really didn't change much. I've been messing with it. I'm not running those current PID on my drone right now, but those settings actually work pretty good. I have no issue with them. I didn't change nothing on the filter or anything else, so we're gonna skip that one. Advanced tuning, and again, I didn't mess with it. Kind of left everything the way it is. Now, one thing I want to bring to attention is the return to home altitude mode. You have a couple altitude setting here, and from my understanding, the list, I just left mine to list, but you can read about, you can do some search, figure exactly what all those different dots. At least is working pretty good for me. Now we're gonna go to our receiver tab. Let me make sure my receiver are working. And again, guys, I'm using a Free Sky R9 Sling. So everything is kind of out of order. So I'm gonna switch my channel mapping to what I use. I use the Spectrum one. And let's go and save. So my yaw are in the right place. Pitch, rocking, roll, throttle. Okay, now I'm gonna go ahead and set up my limits. You can see if I go full positive, I got 2011 on the throttle, and full negative, I got 987. And on the yaw, I got 2011 full positive and 987 on negative. So 2011 on roll, 987. 987 on pitch, and 2011. So we're gonna take care of that. Show the easiest way to do that. You don't need to do anything on your flag controller. You don't need to do anything on your transmitter. You're just gonna go down to your CR command, and what we're gonna tap in is RX range 1, and you're gonna enter the value 987 and 2011. Gonna go RX range 2, that's for a second channel, and we're gonna enter 987 and 2011. I'm gonna go RX range 3. We're gonna enter 987 and again 2011. And finally, we're gonna go RX range 4. We're gonna enter 987 and 2011. No, actually no, that's gonna be RX range. I did a mistake there. We start with RX range 0. We're gonna go 987 and 2011. That should do it. Here we go. And we're gonna tap in save. We're gonna save and reboot. So sorry guys, you start with orange range 0. Don't start with 1.
GPS good.
Oh my God.
Lost.
Remember?
GPS good.
And again, pretty amazing. Okay, let's go back here. So now everything should be, here we go. My yaw go from 2000 to 1000. My pitch goes from 1000 to 2000. So is my hold should be 1000 to 2000, and my throttle should be 2000 to 1000. So just to go back, I did a little mistake here. So
GPS lost. GPS good.
I know, Amber. So your ranges are the RX range what I just did. So you start with RX range 0, RX range. So the way the RX range work is you start with RX range 0, which is your first channel. Then you go to RX range 1, which is going to be the second, RX range 3, which is going to be 2, which is going to be the third, and RX 3, which is going to be the fourth channel. And I did a little mistake. You saw me, I started with 1, but you start with 0, 1, 2, and 3. And that is done here. All right, let's go to the mode channel. Okay, guys, so here, I mean, you're pretty much going to have to set up the Inav the way you want it to fly based on your transmitter. But I'm just going to show you how I got mine set up. One of the things about Inav, which is different than beta flight, it does not give you an automatic option here. So you pretty much has to choose which channel you need to go to based on your switch. Pretty much what I did is go back to receiver tab and kind of mark down where all the channel are based on the switch. Like my arming channel is channel 5, my beeper channel is channel 6. So you just mark down which switch you want to use and which channel corresponds to that switch. But I have my arm switch on channel 5 and my adding old, which is keep your, I mean, it's adding old. I'm not going to go too far into that. I have my adding old, my Inav attitude old, and my Inav position old on channel 10. So if I'm all the way up, the old inactive. If I go to the middle, adding old is on with Inav attitude old, and this is just keeping your attitude in the same place. And if I go all the way down, I got, oops, sorry about that. I got Inav adding old, Inav attitude old, and Inav position old all activated. So that should help keep my drone at least in one area. And that on channel 10. And I got my Inav return to home on channel 7. And that'll be all the way in the bottom.
Return to home.
That's my return to home one now. And I got my Inav mission plan or waypoint still on channel 7, but right in the middle. And all the way down here, that's my beeper on channel 6. And I have my OSD alternative, got it on channel 9. That's my first OSD. That'll be my second OSD, and that'll be my third OSD. So I'm gonna go, since we got here, I'm gonna go to OSD, and I'm gonna show you how I have my OSD set up. That is the default layout. And I'm gonna go to alternative 1. And one I need in here, of course, we need our RSSI. We're gonna need a battery cell voltage. Fly with cell voltage. I don't use the battery voltage. Throttle position and aircraft name. Flat mode. Well, I don't really need flat mode. I mean, I know I'm gonna be, no, actually we need flat mode because this is gonna let you know when your drone go into failsafe and everything like that. So we're gonna keep this one on. System message, we always need that one. And heading, no, we're not gonna use heading. Let's see, what else can I use here? Let's go down. Attitude. Where is my GPS stuff? Here we go. GPS. I'm gonna use a GPS speed. It's always nice to know how fast we're going. Actually, we're gonna use a 3D speed. That is more accurate than GPS speed. So we're gonna turn GPS speed off, and we're gonna use 3D speed. That is a lot more accurate. I think it's calculate your speed not only based on your longitude and altitude, but it's also calculate your speed based on your you're gonna use GPS speed because it calculates your GPS based on your longitude, latitude, and altitude, where GPS speed only use your speed, calculate your speed based on your longitude and altitude. And we got GPS sat number. We go here and you put the longitude and altitude. Just for fun. This is gonna be right here. And direction to home. That's a direction to home. Distance to home. That will be it. Here we go. We got distance to home here. Let's see. I think that should be. I mean, you get the idea, guys. And we're gonna save that, and we can also. That'll be my first one, just to give you an idea how to set it up. And the second one, that's the second alternative. I want to use RSSI. I'm going to use flat mode. I'm going to use system message. I'm going to use my battery cell voltage. And I'm going to use my GPS. Where's my GPS number? Got a satellite number. And in here I want to use GPS speed. That's all I need for this page. And we're going to save that. And we're going to go to the third one. And the third one, the only thing I'm going to be using is flat mode and system message. And that's it. So you get an idea. And now when I switch my, I can switch the, no, that's mission control. We don't need that for now. I may make a video about it to show you how to set it up. So let me show you the OSD alternative work. I got an alternative 1. If I switch my switch, I got to more alternative 2. And if I switch it again, I got to 3. So that's how the whole things work.
Mode 2, mode 3, mode 2.
Okay guys, and this should be concluding this video. That's pretty much all you need to do to run Inav on your Tyro 129 or 119. I may end up posting some more videos because I'm pretty interested to how the mission control mode or Inav waypoint work. So I may post some more video about it, but everything I shows you here, guys, just make sure to make the change according to your to the way you set up your UART and to the way you set up your transmitter as far as channel goes. But everything I shows you should be get you going as far as flying Inav on your Tyro 129 or 119. Thank you guys for watching, and I hope that you enjoyed. If you do, please go ahead and subscribe. I would greatly appreciate it. Thank you guys.